All right, welcome back for episode 2 of Science with Mr. Morrow. Now, there were some questions yesterday about the sketch on the title of yesterday's video. That was done by a former student. My students like to make fun of me about everything, and one of the things they make fun of me about is my short upper body. So she decided to draw me just as a pair of pants peeking over the top, and I thought it was really funny and really clever. So that's the story behind the picture. Now, we're going to be doing a similar experiment today with vinegar again, and a very similar reaction, but then we're going to use what we make today to do some other experiments. So what we have is 3 eggs, normal eggs, raw eggs, they're hard, and we're going to put them in the vinegar here. So go ahead and drop them in, girls. All right. And then now if you'll get in really close, you can see really tiny bubbles start to form on the eggs. And it'll be more evident the longer they sit in there. But what's happening is a very similar kind of reaction as the baking soda and vinegar. You have calcium carbonate, that's what the eggshell is made of, and then the acetic acid in the vinegar is reacting with that. And so little carbon dioxide bubbles form on the edge of the shell, and after 10-12 hours, the hard shell is completely gone. It's changed. The calcium carbonate is no longer there because it's reacted with the acetic acid. Okay, my third assistant is standing up this time instead of laying on the ground. Say hi, Lana. All right, so these have been soaking for about 18 hours in vinegar, and I've changed the vinegar a couple times because these jars are pretty small and didn't have a lot in here. What we're gonna do is we're gonna go ahead and dump it out carefully. Leave the egg in there carefully, girls. Okay, good. You set the jar to the side. And I'm just going to rinse them off a little bit because we're going to touch them and they're kind of nasty.
Oh my gosh, that's gross.
Yeah. Go ahead, take one. There you go. And if you can look, this is a raw egg, but the shell is gone. They're bouncy, squishy raw egg, but no shell. And what we have here is a membrane that's very much like a cell membrane, and it's semi-permeable, which means that some things can pass through it and some things can't. So obviously the contents inside right now, the egg white and the egg yolk cannot pass through, but water is able to move through this membrane in and out. So to finish this experiment, it's going to take some more time. We're going to get it started. We're going to use 2 of these eggs. We'll use Ellie and Mila's eggs. And what we're going to do is we're going to put one in purified water. Go ahead, Mila. So that's just pure water. And the other one's going to go in Karo syrup. Go ahead, Ellie. Drop it in there. And we're going to go ahead and cover it up with this nasty syrup. So, the Karo syrup is a solution that's very concentrated. There's a high concentration of sugar dissolved into this liquid. And then the purified water is a concentration or a solution which has a very, very low concentration of solutes. There's almost nothing dissolved in it. It's almost pure water. And so the way this works is in a process called osmosis, water will move across the membrane. In the pure water solution, the water will move into the egg to try to balance out the amount of solutes that are inside the egg and outside the egg, just like happens with cells. In the Karo syrup solution, the water will actually move, water that's inside the egg will move outside of the egg into this really concentrated solution to try to balance that out. What it's trying to do is find equilibrium, and your cells do the same thing. So we'll check back in a couple of hours and we'll make observations about these eggs and see how they've changed.